Welcome back, everybody. This is our video solution to problem 6 from Superquiz 1. Here we are going to compute a couple of integrals, but not by using the fundamental theorem of calculus. Note the underlined and italicized without using the fundamental theorem of calculus. Instead, we just want to use our interpretation of the integral as accumulation. So let's look at this first integral. This is asking us to compute the accumulation of the function 2t plus 1. That's just a line, right? So let's draw a picture, right? 2t plus 1, let's see. That means the y-intercept is 1. Then it's going to go up at a slope of 2. So if I went up to 1, that'd be at 2, 3. So I can draw a nice line and okay. Okay, there we go. And I could come over here to 4. Okay, let's see now, how high would it be at 4? I'd have 2 times 4 is 8, plus 1 is 9. So way up here, all right, I get a value of 9. So this integral is asking me between 1 and 4, how much does this function accumulate? Right? It's just the area under this curve, and this is just a trapezoid. Right? A lot of ways one could go about doing this. I like using the trapezoid formula because I know it, right? So you just take the base, which in this case, how far is it from 1 to 4? That's 3, times the average height. Okay, so here on the left-hand side, you have a height of 3, and on the right-hand side, you have a height of 9. So the average height is 6. All right. Okay, and you can see this triangle and this triangle are the same, so it's like building a rectangle with base 3 and height 6. So this area, right, this area is equal to 3 times 6, which is 18. Hey, that's what they suggested it was going to be. Okay, alternatively, you might break this up as a rectangle plus a triangle and then work out the areas that way, right? Lots of ways of skinning this cat. Oh, that's sad. I love cats. Okay, what about this second one? Well, this is much more complicated looking. I mean, who in the world is dealing with a 197th degree polynomial? But one of the things I notice immediately is that is an odd degree polynomial, and this is an interval that goes from a negative number to the corresponding positive number, right? And we have a result that says if f is odd, which remember odd means f of negative x equals negative f of x. And the reason why we use this odd here is because odd degree polynomials, right, or monomials rather, odd degree monomials are odd functions. So if that's true, and you integrate from negative a to a, you always get 0. Why? Because this relationship is telling you your graph has to look something, let's do it the other way. It has to look something like, maybe like this, all right? Where this is symmetric. Okay, that's just a really bad symmetric drawing. Okay, so let's say we're going to go this way, and maybe we'll go this way, right? Okay, and so before and after, they're the same curve, just one is positive and one is negative. And so when you integrate from the same spot on the left as from the right, these are going to cancel out. So you get 0. So if we break this up into 3 pieces, one based on this first, one based on the second, one based on this third, at least the first 2 of them are just going to give us 0. So I can break this up, right, with 5x to the 197. Oh, that should be a t, shouldn't it? Okay, this will be fixed in the exam. Okay, so we have 5t to the 197, and then we also have one from negative 10 to 10. Oh, there's a minus here now, 3t to the 5th. Okay, and then we have this last bit. It'll go from negative 10 to 10, but we just have the 7. And these two, right, being odd functions here, right, that's odd, and that's odd. These are going to both give me 0. So the only one left is this 7. Now 7 is not an odd function, it's an even function, but my goodness, that's going to be an easy one. I just draw here from negative 10 to positive 10. It's just a rectangle, all right? I'm just drawing a rectangle. The base is 20, and the height is 7. And so I end up with 140. Which is what the answer they gave me was. Nice.